complex ion tu. The first one is oxidation state, and then the second one is the type of ligand. Dua tu je. Okay. Right. So jom kita tengok soalan handbook. So kalau kita dah buat hari ni, so korang tak perlu dah buat dah apa ni. So if you look at your handbook, so the handbook you are given with how to naming the ligand apa semua tu, how to name the complex ion and so on. So if not mistaken, benda tu dah tak ada dalam syllabus. Benda ni just to add on punya general knowledge sahaja, okay? Okay, so a transition metal ni, let's make it very simple and short to understand. If you look at the sodium chloride, tengok, itu garam lah. So the garam, the formula dia adalah sodium chloride. So it consists of two atoms ataupun two elements. So benda tu dia tak kompleks lagi. But if you look at the complex ion ataupun transition metal, so the transition metal can form the complex ion because first dia punya charge, okay, dia punya charge lah, charge of the metal. The second one, dia ada platform for them to make a complex ion. Sebagai contoh dia chromium Cl6. So chromium Cl6, chromium Cl6 3- ni. What is look at the central atom. When you want to talk about the complex, look at the central atom, then you just write the electronic configuration. So you have argon, then OS2, chromium is a 3D4. So if you expand the structure tu, this is 4s2, this is 3D. So the existence of the empty orbital yang lain tu that allowed the complex ion to can form. Dia bukannya konsep macam hybridization ke sharing, tak, dia adalah secara dative. So what I'm trying to say is lepas 4s 3D, then we have 4p, tapi 4p ni adalah empty orbitals. Since the higher energy level for the transition metal adalah 4, so therefore dia ada orbital S, P, D and also F. But the electrons only occupy until D orbital. So bermaksud P orbital is still empty. So the ligand can form dative bond. Member sampai bila type of covalent bond dia adalah dative bond. Right? So that is how the transition metal can form complex lah. Hello?
Terkeluar
Tadi
tadi.
terputus. Tadi terputus ya. So, sebab masa saya explain tadi tu, suddenly saya tak pasti sama ada online ke tak, tiba dia keluar, lepas tu dia connecting balik. So, tadi saya stop sampai kat mana? Saya explain pasal additive bond tak?
Saya start sampai situ je.
Sampai situ So, itu formation of complex, right? Saya share sekali lagi screen. So, if the question asks you, dalam formation of the complex ion tu, the word complex tu because it consists many ligand je lah, itu je maksud dia. Like by referring to the sodium chloride tu, so the chloride only got 2 atom kan. So but this one got 6 ligand, so dia considered as a complex compound ataupun complex ion. And this ligand form secara dative bond. Kat mana dia form dative bond? Dekat empty space yang ada dalam transition metal tu. Okay. So if you look at the textbook again, adalah how to name the ligand. So kalau Cl is chlorine, but when you have a charge, negative charge, then we call it as a chloride. And for ligand, we don't call it as chloride, but we call it as a chloro. Kalau bromide, dia akan jadi bromo. So the same things, tapi dia adalah, if you say it as a chloride, then dia adalah sejenis anion. If you say as a chloro, then sometimes it can be a ligand. Macam itulah kan. So, just for your general knowledge,
Yang dative covalent bond tu dia isi dekat 3D orbital yang kosong.
not 3D orbital, tapi any orbital dekat level 4 yang kosong.
Level 4 tu include 4P.
Yeah,
Okay, sir.
include 4P. Right, so sulfate dia akan jadi sulfate tu. So this is only general knowledge lah. Can have a look. So the neutral ligand, water is it's called as aqua, ammonia jadi amine. Orang macam tu. So names of the complex. Kalau kita nak names of the complex ni, we start from right to left. So kita baca daripada kanan ke kiri. So dekat kanan we have 6. So dia jadi hex kan. Kalau 4 jadi tetra. Tentulah. So hexa aqua. So jadi hexa aqua chromium. Because of positive charge. See? Positive charge here. Tapi kalau let's say I change instead of 3 plus then become 3 negative, so dia akan jadi hexa aqua chromate. Kalau negative charge dia akan jadi tambah ATE tu. Okay. Kalau dia negative charge. So let's look at the example given kat ni. So this is hexa aqua chromium 3 ion. So dia must be using per Roman numerical, or tak boleh buat bracket 3. So this is only general knowledge saja. If the complex contain more than one kind of ligand, so dia ikut alphabet macam this one. A dahulu baru B, betul tak? So try aqua, chromo, copper. So if the complex ada negatif, this one kita tambah ATE. So yang saya tunjuk ni hexachlorochromate. So tetra bromo cuprate. just for general knowledge. Okay, when we talk about oxidation state of the transition metal, all of them will have positive. Scandium dengan zinc is not transition metal because scandium against the pattern ataupun the trend character that all of them must possess with +2 oxidation state, tapi scandium tak ada. Zinc yes have +2, but the thing is zinc don't have variable oxidation state. So we don't consider zinc and also scandium as a transition metal. Sorry, a transition state. So we just consider it as from titanium to copper saja. See, paling banyak sekali manganese sampai 7 ada. So the general fact is all transition metal has a common oxidation state is +2. All of them. Okay. Which one of the following represent the correct electronic configuration of an isolated chromium 3 ion? So we know chromium tu ada apa? Ada 24 elektron. So kita buat condense, so argon 18. So mestilah argon ni akan lebih sekat P kan. So 4s2 and also 3d4. But for the ion, remember we remove the electron from 4s first. But this is 3 plus, so we remove 2 electron from 4s2 and 1 electron from 3d orbital. Therefore, the electronic configuration for Cr3 plus is macam ni. Jawapannya adalah Denmark. So ya cara dia.
Sir.
Majority student akan remove electron from D. No, when you talking about ion, we remove electron from 4s dahulu. Siapa panggil saya tadi?
Yang CR tu bukan 4S1 3D5 tu.
4s1 3d5. Okay, good. Dia adalah, yes betul. Dia adalah 4s. At first, we write as macam ni kan. 1, 2, 3, 4. Semua elektron akan jump ya. It's a 4s1 3d5. And when we remove 2 electrons, remove 3 electrons, then you will have this. Okay, which one of the following provide the most satisfactory definition of transition metal? Most satisfactory definition for transition metal. A, B, C, D.
B.
Has variable oxidation state in its compound. Form an ion with a partially filled D subshell. Itu tak diterima. Okay, jawapan yang paling tepat sekali adalah occurs in a D block. Okay, tak boleh because ada scandium dengan zinc. Has variable oxidation state in its compound. Ini adalah jawapan yang paling tepat among them lah. Okay. Form an ion with a partially filled D subshell. Pun boleh juga tapi D is the best one. Lies between scandium and zinc. Kalau scandium and zinc untuk period 4 saja, how about period 5, 6, 7, semua tu yang they also consider as a transition metal. So, tak tepat sangat lah. So, Transition metals are the only element which mana? Form colored ion in aqueous solution. Form complex ion with hydroxide ion. Form covalently bonded anhydrous chloride. And show an oxidation number higher than 4. Agak-agak awak yang mana paling tepat? A, B, D. Show an oxidation number higher than 4.
I think so, sir.
Ni tak higher than 4 pun. Boleh diterima tak? The only one yang ada oxidation higher than 4. Tapi copper tak ada kan? How about form complex ion with a hydroxide ion? So dia kat sini nak cerita tentang selalunya kalau hydroxide ion ni dia akan form apa? Let's say ambil NaO lah. Dia akan form electrostatic ionic kan? But this one dia akan form complex ion. So jawapan dia adalah A. Form complex with a hydroxide ion. But other than that, NaO ke ataupun you have MgOH ke, so mereka semua ni secara ionic kan, charge. But the transition metal, they can form complex. So number 3 tu compared to the S block metal, transition metal generally form compared to the S block metal. So ni oxide is more basic ke, oxide is more soluble, salt which are more ionic, ions which are reduced more readily. Is the oxide is more basic. Oxide which are more soluble, salt which are more ionic, ion which are reduced more readily. So the answer is D because they can have more than one oxidation number, so dia boleh senang berubah. Like let's say you have Cu2 plus. So if you add a different ligand, so dia boleh jadi Cu plus, sort of macam tu. And number 4, which one of the following ion is colorless? Anyone? This is simple question.
D.
Bola.
Dadu.
Yeah, the answer is D because the presence of zinc. Which one of the following ion will catalyze least effectively? Agak-agak yang mana least effectively? Titanium, scandium, iron, chromium. Anybody? Number 5 ni siapa nak try? So saya panggil ke saya panggil nama? Panggil Abdul Aziz.
Yes, sir.
Answer me question 5. What is the answer?
Wait. Is it at least
Yeah. What is your answer?
B sir. A.
B stand for
Ferrum.
ferrum. Okay, good try. Okay, well done. So the answer is C. So because scandium is not transition metal, so scandium has no catalyzed catalyst property. So all the transition metal has the catalytic property because of 3D tu dia ada electron. But for scandium 3 plus, they don't have electron at the 3D. Which one of the following metal form the complex ion and M ni? M tu probably stand for apa benda agak. This is very simple kan. So, is it copper, silver, scandium ataupun lead?
Copper.
Okay, good. The answer is copper. +2 and also +1. Kalau confused, awak tengok kat sini. Siapa yang antara mereka can form positive one? So, copper or nickel. It's the three commonest oxidation state of manganese. You can refer later. Okay, cukup lah takat tu. Nak test korang punya ni saja. So, let's continue dengan kita punya slide. Okay, kita sambung sikit pasal color compound dekat faktor dia. So, like I said just now, factor can only two factor that determine apa yang buatkan dia punya color compound tu berbeza, the presence of the ligand. So, this is a very good example. So, the charge of copper is 2 plus, same for the right side because all these ligands, aqua, amine dengan ni adalah zero charge. So, meaning that the copper charge is the same, Cu 2 plus. But why the color is not the same? This one is blue and then this is slightly darker blue because the presence of ligand dalam complex 2. So we have to look at the component of ligand in the complex. Okay. So the second factor is and of course so why different ligand tu can cause different color because they have different strength and they can cause the strong ligand akan replace the weak ligand, right? The strong ligand akan replace the weak ligand, and the strong ligand tu dia akan ni lah split lagi besar. So the second factor is the oxidation state. So you look at the different oxidation state. So got the chromium, and the ligand is the same, aqua ataupun water. And the only thing is the charge for the chromium is different. So you can see that the color is not the same. Satu hijau, satu biru kan. So the second factor is the oxidation state of the transition metal. Okay. second factor adalah oxidation state of the transition metal. Okay, smaller size allow ligands to bond closer. This is common sense when the when the metals tu ada higher charge oxidation number dia, higher oxidation state dia tu. Actually the metals tu akan menunjukkan lebih character of covalent. So some of you might ask, kenapa let's say CrCl4 2 minus. So when I say this is a covalent bond kan, covalent bond, some of you might think kenapa dia tak jadi ionic, because of chlorine ataupun chloro tu is negative charge and chromium is a uh, is a positive charge. So kenapa dia tak? Because of size is small. So when size is small, so dia akan allow ligand to bond closer and suddenly they will have more covalent character than ionic. So they will have more covalent character. So of course dia akan, bila dah ligand tu dekat, dia akan create greater repulsion lah because dah rapat kan. So when the ligands battles among themselves during repulsion, yang terbabit adalah 3D orbital. So dia akan split larger. So that is how the ligand causes splitting 3D orbitals. And of course bila dah distance tu besar, require more energy to jump to the higher energy level, and then it will absorb more energy of wavelength ataupun shorter wavelength and transmit. Macam tu je konsep dia, okay. So selain tu adalah identity of the metal ion itself. So the identity of the metal ion, of course lah, chromium dengan copper berbeza, so they also have the different color possessed by them lah. See, iron 3 plus more in size but greater number of proton. So ligand pull more closely and greater repulsion, and then they can cause again the peak gap. Macam tu lah konsep dia. Okay, what does it mean by ligand substitution? So kita tahu that ligand has different strength kan. So the weakest ligand basically is a group 17 punya ion lah. Iodo, chloro semua tu. And then the strong ligand punya thiocyanide, cyano tu. So if you have iron as a metal and also the transition the ligand used is a water ataupun aqua. So when you add thiocyanide, so dia akan berlagu ligand substitution terpanggil. So you have to imagine that iron bracket aqua 6 ni dia punya bentuk adalah like this. So dia ada bentuk dia ni octahedral kan. So dia octahedral. So they have 6 aqua surrounded by the iron 3+. So all these aqua can be substituted by another ligand. When you want to substitute with another ligand, then we have to use a strong ligand than water. So if you add thiocyanide, so dia akan replace the aqua ni dengan thiocyanide lah. So one aqua tu remove and then substitute with the thiocyanate. So jadi dah macam ni structure dia. When you just substitute one ligand, so the color terus berubah. So the color terus berubah. That is a ligand substitution.
Rasa
Mm-hmm.
kalau substitute ligand tu tukar charge dia sekali
Tukar charge dia sekali.
Charge of the central.
Charge of the metal still the same. This is positive 3. And this is also 3 positive kan. But the thing is, the the cyano tu dia ada negative charge. So the panggil dia sebagai overall charge of the complex now become 2 plus. So the charge of the central atom ataupun central metal tu still the same. Still the same. Dia just substitute the ligand sahaja. Okay. And jadilah color blood red no. So this is the equation. So you have to know how to write the equation. You see the question carefully to the bracket kan. Bracket, if you have more than one, so you have to put bracket and then put the number lah. Silap sebenarnya. Oh, this is chlorine, so 2 different ligand. Habis untuk ligand tu lah. So this is our panggil diagram. You can see the blue color is a metal ataupun transition metal. L is a ligand. So ligand akan come from different angle and form inilah kita panggil octahedral. So X, Y, X, Z, Y, Z semua tu. Okay, any question?
Yang ligand substitution tu tak ada tak ada rule. Macam dia apa-apa je boleh substitute.
Dia sebenarnya depend. Ligand substitution tu general rules dia adalah the strong ligand akan substitute the weak ligand. So that is the punya statement dia. Okay, let's see the question from the IB question bank. Susah tak sebenarnya topik ni? So color complex. Let's see question. Oh, which factor does not affect the color of a complex ion? Straightforward dia kot soalan ni. Anybody? Siapa yang nak dapat 7?
A ke sir?
Yeah. How confident with your answer? Tell me. Is it 100% ke?
80%.
80%. Okay, so 80% kira yakin jugalah tu kan. So jawapan dia adalah A. Did I mention any concept about temperature ke during tu? Tak ada sangat kan. So the answer is A. Tak ada komen Pak, senang sangat. So identity of the ligand tu, the ligand species lah, water ke aqua ke kan, cyano or bromo ke apa-apa saja. So that is a type of ligand. But if you look at the soalan tu, identity of the metal means that identity of the transition metal lah. And then the oxidation number. Mana yang susah lagi? Transition metal like iron can form complex. Discuss the bonding. Okay, good. In terms of acid-base theory. So, missing acid-base theory saya tak mention dalam slide tadi tu. So, you know the process of formation complex tu macam mana? Secara what type of bond kita pakai?
Biasa
Siapa
cakap
nak
datif
kongsi?
kan?
Yes. So when we talk about complex, the first thing adalah dia form secara dative. Dative ni say there's covalent bond, right? So dia donate 2 electron from the ligand. That is why when you want to form the complex, only ligand yang boleh because ligand ni is a high rich species. So secara dative. Okay. And the second point adalah acid base character. So kita ada acid base secara contohnya H plus or hydroxide. So tu orthodox lah Arrhenius contohnya. And then kita ada secara Bronsted-Lowry. So the last one kita ada Lewis acid base. So in term of the acid base theory, teori mana kita nak pakai? So the first one, Arrhenius, is based on the dissociation of acid and also dissociation of alkali. Kalau Bronsted, it's all about proton transfer in and out. The one that release proton is called acid. The one that receive the proton is called basic. And the Lewis acid and base, it's all about electron transfer in and out as well. The point not transfer out, not electron transfer, electron donate and electron accept. So agak-agak awak, teori apa yang kita boleh pakai untuk discuss the bonding ni? So the bonding tu dah dapat jawapan, dative. The second one, in term of acid base, yang mana? Arrhenius, Bronsted or Lewis?
Lewis ke sir?
Lewis ke sir? Awak tanya saya balik, saya tanya awak, awak tanya saya balik. Right, so the answer is, yeah, Lewis acid and base. So it's only 2 marks. So let's see the answer. Okay. What does it mean by coordinate covalent ataupun dative? Coordinate covalent ataupun dative bond tu nama lain lah. So when you want to explain, sebab dia minta discuss kan. So when you want to discuss, you have to ada comparison biasanya. Metal sebagai apa and ligand sebagai apa. So in these cases, discuss the bonding. So we discuss that the bond formed between ligand and transition metal adalah dative bond. So you will get 1 mark from here. And then the keyword here adalah or. So either you want to explain in detail that ligand donates pair of electron to the transition metal, ataupun you just simply say that ligand and metal form dative bond. So examiner we understood and you deserve 1 mark. But for the second mark, cakap discuss the in term of acid and base theory, so you have to be specific. Ligand as a Lewis base and metal as a Lewis acid. So kalau kita buat ulang kaji sikit, so H plus hydroxide ataupun iron 3 plus. So dia akan donate. So the one yang donate lone pair tu kita panggil sebagai Lewis phase. And the one yang accept ni sebagai Lewis acid. So, kalau hydroxide ni dia donate lone pair tu dekat H plus, so H plus ni kita panggil sebagai Lewis acid. And then this is also Lewis phase. So sesuai lah kan, hidrogen tu menunjukkan sifat keasidan. Okay, clear so far? Any question before we proceed to the next properties? Ataupun korang nak tengok soalan-soalan contoh lagi ke? Itu free and easy. Tengok soalan lain pula . Inilah banyak kita belajar satu markah je dia allocate untuk ni. Boleh kan? You just giving a reason which complex cyano ataupun OH hydroxyl absorb higher energy light. Use section 15 on the data booklet. So take your data booklet and then look at page ataupun look at the section table 15 tu, section 15. So it's section 15 about spectrochemical series. And if you look at the ranking system tu, let me write down for you. Section 15. OH CN. Okay. Cyano is stronger than hydroxyl. Agak-agak awak yang mana absorb higher energy light? Bahkan korang tiba-tiba korang jadi seorang yang pendiam, so saya panggil nama lah. Jadi kita dah panggil Tok Bilal gitu, sekarang kita panggil Alia Zulaika.
Yes, sir.
Can you share your answer to us?
Setang tadi cyano ke
Soalan ni je, soalan B. Question B. Which one yang antara this complex yang mana absorb more light, absorb higher energy light?
My
So all
answer
of them.
is yang cyano.
Cyano absorb more light.
Yes.
Okay, the next question. Hexahydroxychromium ni dia form a green solution. Hexahydroxychromate negative charge kan. Estimate a wavelength by using section 17. Kalau wheel tu. So yang ni awak kata dia akan split lagi, dia akan absorb more energy. So this is your answer. Untuk yang ini pula, estimate wavelength yang dia akan absorb using section 17. Kawan, what is the answer? Alia Zulaika.
Just saya tak sure.
Refer to the data booklet and then give your answer to us.
491 nanometer to 575 nanometer.
491 to
575.
575. So, wavelength yang diabsorb adalah 575. That is your answer, confirm? Okay, tak apa. Kita tengok dulu jawapannya. Alright. Kalau salah tu biasalah kan kita belajar, okay? Okay, view details. Let's see. By any value ranging from 647 to 700. So dia bermaksud dalam range warna merah ataupun complementary color dia. That is the right answer sebenarnya. So yang untuk yang first one tu, the answer is CRCN. Okay, betul, but you have to explain why you choose this. Because CN is a strong field ligand. Okay. So you want to write your answer sesimple ni pun diterima juga. Tapi kalau secara konsep dia, like I said, the strong ligand akan cause splitting to besar. So thus akan require more energy to excite the electron. Okay, satu lagi, lepas tu kita akan continue the next part of the topic. Okay, anyone? Which statement can be correctly deduced from the series? Alia pilih satu nama. Jadi awak dah jawab kan. So as a reward, awak boleh pilih satu nama kawan awak jawab soalan ni. Ataupun awak boleh pilih diri awak sendiri. Pick one name, Alia.
Oh, serius. Saya tak sedap saya lagi.
Awak nak jawab
Ellie. Bukan. Tak.
orang lain.
Saya pilih Ellie.
Ellie Ariana.
Yes, sir.
Okay ke?
BB, sir.
BV which statement can be correct? Lee deduced from the series, water increases the DD separation more than Cl negative. Okay, let's see the answer. Soalan ni senang je kan? So, jawapannya B. Okay, so kita rehat around 5 minutes dan nanti kita akan sambung dengan next part of the transition method, okay? Bolehlah awak nak pergi buat kopi ke apa ke? Okay, kita sambung sikit lagi. This is second part yang kita akan discuss. And then the last part adalah magnetic properties for the transition metal. Tapi saya ingat yang itu mungkin kita sambung next class lah kot. Kan? So dalam minggu ni juga. And then insyaAllah by this week kita akan habis all the syllabus for IB ni. Then kita akan buat revision. So formation complex tadi saya mention sangat surface. Just to give you an idea what is the complex ion maksud dia. So again, I want to emphasize because of the ligand, the species that negative or neutral that have the lone pair. So the lone pair tu yang akan digunakan untuk form complex. Besides that, the size of transition metal is small, and also bila the size dia tu kecil, and then dia punya oxidation number dia pula tinggi. So dia akan ada great, kita panggil dia high charge density. So density dia tu sangat tinggi compared to sodium. We learn that across the period. Kalau ingat lagi dulu kita belajar for the periodic table ni, dia punya trend from across the period from left to right, the size getting decreases kan. So sodium compared to the magnesium and then compared to the rest ke kanan tu, so the size getting smaller and smaller kecuali group 18 gas. So for the transition metal sama, adalah kecil and then dia punya charge tu tinggi. That is why the covalent character so is prominent dekat situ. That is why dia form dative covalent bond. Selain daripada the energy level ada fourth energy level, therefore dia ada SPDF. So PDF tu empty, so they can use that empty orbital to form dative bond. Okay. So when we look from the point of view of acid and base tu, transition metal tadi kita mention akan jadi Lewis acid, receive the electron, so they receive the lone pair electron tu, then the ligand always Lewis base. Ni macam tadi juga, I just repeat balik. The dative bond, make sure you show the arrow tu, and the arrow must come from the lone pair. So this ligand is zero charge, but this one cyano is negative, negative, negative. So you can see that negative, negative, negative. So ada 6. So you akan ada different oxidation number. Total oxidation number of complex tu berbeza. So for the IB, we only talk about octahedral shape sahaja. So when the question suddenly asks you what is the coordination number for, what is the coordination number for this complex? So jawapan dia adalah 6. The coordination number always refer to the ligand. Dia punya concept dia. So you have to refer to the ligand. How many ligand that form dative bond to the metal? So in this case ada 6. So therefore the coordination number adalah 6. So coordination number tu nama glamour sikit bagi dative bond lah kan. So kalau ditanya how many dative bond form, macam tak gempak sangat. So they have to use another term called coordination number. So let's look at the type of ligand. So if you look at the word monodentate ligand, bidentate ligand, polydentate ligand, pernah dengar perkataan macam tu tak? Anyone? Pernah dengar tak? The word.
Pernah.
Siapa kata pernah ni? Arif kata pernah ke?
Tak pernah
Kalau awak-
sir.
Pernah rasa?
Pernah Okay. Kalau let's say lah awak mandi kan. Kalau saya dalam ambil shower tu, saya suka tengok dekat belakang tu. Shower gel ke ataupun shampoo ke apa chemicals yang dia pakai. Supaya, yalah, nak menghabiskan masa ketika mandi tu, terbacalah apa yang ada kat dalam toilet tu. So, mesti awak akan familiar dengan perkataan EDTA. Ethylene diamine tetraacetate. Is any one of you familiar? Aku pernah dengar tak EDTA, EDTA. So, mungkin awak boleh apa, ketika tengoklah kat awak punya shampoo ke, sabun ke kan, tu ada tak perkataan EDTA. So, kalau awak tengok kata tu, then you have to imagine this structure. So, kena imagine this structure. This is EDTA. Okay. The word dentate ni sounds macam dentist. Dentist tu siapa? Do you know dentist? Doktor gigi lah kan, dekat tak tahu betul tak? So dalam 3-4 bulan pergi jumpa doktor gigi, kita nak buat scaling ke apa ke kan. So the word dentate tu actually dia bahasa not mistaken Greek kot. Maksud gigit tu ataupun gigi. So monodentate maksudnya ada satu gigi lah. So kalau you have bidentate bermaksud you have dua gigi. If you have more than two, so dia panggil sebagai polydentate ataupun more, lagi banyak lah kan. So you have to understand that the gigi is refer to this yang boleh form dative bond ataupun lomper yang berguna lah kan untuk dative bond. So let's say for chlorine. So kalau dia jadi chloride contohnya kan. If you look at the lone pair, ada 1, 2, 3, 4, ada 4. Tapi when they form dative bond, they only can use one saja. So only one side can be used for dative bond. If this side already used for the dative bond, lagi 3 ni takkan jadi donate lah kan, tak mungkin. So this is a monodentate. Look at the bidentate. 2 side for the panggil apa, to form complex. So if you look carefully here, so dia punya bentuk adalah macam so akan ada satu, so ada 2 side for the dative. So ini adalah, nama dia adalah oxalatoligand ataupun oxalate. This is structure of oxalate kan. So dia ada 2 side that can form dative. So kita panggil dia sebagai bidentate. Tapi kalau kita tengok dekat tetraamine acetate ni, sudah ada banyak kan. So they call it as a polydentate. So penting ke benda ni? Penting lah dalam industri kan. So industri sangat penting. So this is another example of the monodentate, bidentate, and then tridentate. Do you need to know all the structures semua ni? I don't think so, tapi you have to understand that ligand tu ada mono, bi, tri and also polydentate. So the word dentate tu is come from the word Greek lah yang bermaksud gigi kan. So how it's a site for the covalent bond. So water is a monodentate. This is also benda-benda ni monodentate. So all of these are complex ion. So how to get this value? Okay, now I want to ask you. Aluminium is a transition metal ke tak?
Bukan.
Bukan. So what is the color form agak-agak if they form complex?
Colorless.
Okay, dia akan jadi colorless. Very good. Same goes to the scandium, same goes to the zinc, semua tu kan. Dia akan form colorless. They can form complex, but the complex is not colored complex. So how to get this value? I guess you know how to get the value. It's a very simple formula. Tapi saya tulis jugalah kan. So the charge tu kita ambil transition metal plus charge of ligand. Itu je. If the transition metal is a positive 3, so ligand is a neutral. So the overall charge akan jadi 3 positive. So very simple, straightforward. Benda yang sama je. So how to draw the complex? Overall charge on complex ion metal ion in the center, and then ligand ataupun ligand dekat surrounded je. Ni tak ada apa. This is naming saja. You can refer to the handbook tu dah bagi. Okay, look at the color of complex ni. Okay, lagi. Tetrachloro, copper, yellow, tetra aqua, blue, tetra amine, dark blue. Dan hexa aqua cobalt, tetrachlorocobalt. So when you add a chloro to the water, so there is a ligand substitution. So the color akan change. So the question dia akan tanya macam-macam lah. What is the process when hexa aqua cobalt ion ni change color from pink to blue when added with chloride? Apa chloride? Chloride contohnya. So the answer is ligand substitution. When the charge of the transition metal remain the same, only ligand yang berubah, so the color change due to the ligand substitution. When the charge of the transition metal berubah but ligand still the same, so the color of complex tu berubah because of change in population number. So be careful with that, right? Okay, habis untuk hari ini. Ada satu lagi part, magnetic properties. It's very simple. Just to give you an idea yang even though all of them are metal, tapi not all of them will have the strength ataupun magnetic property yang sama kuat. It depends on the depends on the arrangement of electron dalam arrangement of electron in the electronic configuration. Tapi itu saya akan ajar maybe next class. Untuk hari ini setakat itu sahajalah kan. Ada apa-apa nak tanya? Kita ada dalam around 15 minit lagi. So 15 minit, 17 minit. Panjang tu.
Sir, I want to ask, tadi waktu kita nak tentukan the overall charge of a complex ion, kan kita tu kan ambil the charge of the transition metal tambah the ligand. Ligand tu kita tambah each one ke salah satu je?
Kita tambah semua. Let's say kalau complex tu got 6 ligand, all of them individual ligand. Sebagai contoh dia macam ni ya. Let's say I have a CL4 2 minus. Okay. So when you want to determine the 2 minus ni, saya bagi lagi. So let's say Cr use is a Cr2. So chloride is a -1. So some of them, so chromium is a +2 and then chloride -1, but you got 4. So total is -2. This becomes 2 negative. So macam tu. How many ligand that you have? 4. So each of them you have to count. And then you have to add together with the transition metal and then see what is the overall. If you have more than one ligand dalam tu, okay, no problem. So you just tambah je semua. Let's say water, the 5, then you have Cl. And then the copper tu, let's say I use copper 2+. Then water, the charge is 0. But Cl, the charge is 1. So overall charge of the ion is positive. So by looking at the overall charge of the ion, I can determine that what is the oxidation number of copper used by compare with the water and also chloro dan chloride. Jelas tak, Arif?
Jelas, sir.
Okay, any more question?
Sir, kalau nak slide sir tu nanti boleh ke?
Ya, saya akan bagi slide lepas ni. Mungkin boleh awak baca kan? Awak tengok ke?
Okay, sir.
So, maybe we can dismiss now. So you have around 15 minutes. It's up to you. You want to take a break to prepare your mental for the next class ataupun if you want to do the exercise dalam handbook then you are free to do so, whatever it is, right? Dan yang ada satu lagi part magnetic properties yang mana minggu ni akan habis the whole topic. And then cara saya adalah when we finish the topic, kita akan I will do survey dan tengok topik mana yang orang nak kita fokuskan. Right. So thank you for your cooperation, and I think we stop now. So get some rest, prepare yourself for the next class, and then you can try to answer the question in the handbook. And then if you have any problem, just text me. If I reply it late, maybe saya drive ataupun handphone saya nak main ke apa. Kalau saya dapat ni, saya akan reply. Right. Thank you and have a nice day. Bye-bye. Assalamualaikum.
Thank you, sir.
Okay, sir.
Thank you, sir. Assalamualaikum.